have an answer? I see a couple people staring at calculators like they have
I'm not
something.
sure this is correct, but I got 11,181.966.
So 11,181 point something
.966.
units.
Meters per second.
It should be somewhere around there. I know it's 11,000 something. Same thing? Okay. So it's 11,181.966 meters per second. So a little over 11 kilometers a second. If we can get something going that fast, theoretically, it's going to leave the Earth and not come back. This is the escape speed for Earth. If I kept the same mass, so what do I want to do? If I kept the same mass of Earth, but I shrunk the Earth to a quarter its current size, or made the radius a quarter of what it currently is, then that would cut my escape speed. Let's see, same mass, smaller planet. So if I cut this by a quarter, that would basically double that. So if I took the Earth and shrank the radius to 1/4 of what it is right now, the escape speed would be 22,000 meters per second. Ish. Or if somehow I increase the mass of the Earth, then I would increase the amount of how fast it needs to go in order to escape. So, what if there actually was a maximum speed? In theory, because in classical physics, which is what we're doing right now, if I kept the mass the same but just kept making the size of it smaller and smaller, well, this would keep going up and up. If I made this, really tiny, this becomes really huge. But if there is a maximum speed, that limits some of what we can change there. And in fact, there is a maximum speed. So I'm going to start with this equation here. I'm going to just flip along the diagonal. I'm going to flip my radius and my speed right there. So Rx is equal to 2gmx over v squared. So if there is a maximum speed, which we'll use the letter C for, that maximum speed, and this becomes 2g mx over c squared. This is the formula for what's known as the Schwarzschild radius. Or the classical approach. And so if we take our sun, if our sun suddenly started shrinking down, kept the same amount of mass, but shrank down, at what point will something no longer be able to escape? Because we're at that maximum speed. All right, the maximum speed is approximately 3 times 10 to the 8th meters per second. This is the speed of light. And so anything traveling slower than the speed of light will never actually get to the speed of light. It's a barrier. Theorists have come up with something that they said, well, if it starts out faster than the speed of light, it'll never go slower than the speed of light. They made up a name called a tachyon. If you watch Star Trek, occasionally tachyon shows up. But we can figure out what the size of our sun needs to be so that nothing can ever escape. In other words, how big does our sun need to be so it is a black hole? So that's 2 times 6.67 times 10 to the negative 11th times the mass of our sun, which is 1.99 times 10 to the 30th, divided by the speed of light squared.
2,949.622.
0.62 something, 2, okay.
222.
Units,
Meters per second squared, no, C, what is that?
the radius.
Radius,
So what would the units be?
wow. Meter.
Yes, meters. It is a radius, it's a distance. So a little under 4 kilometers. Anyone else, oh, sorry, anyone else get, I know it's 3,000 something. Anyone else get the same thing?
I got 2,949.
Oh, 2,000?
Oh, that's what I thought.
Oh, all right. So I know it's around 3,000. All right. So a little under 3 kilometers. So if the sun, our sun, kept all of its mass, but shrank down so that its radius is at roughly, Peters Creek to Haynes Mall? Is that about 3 kilometers? We'll pretend for now. I'm in a ballpark. So if our sun shrank down to that size, the sun becomes a black hole. So if our sun suddenly, magically, somehow managed to take all of its current mass and shrink down to that size, what would the Earth do? So we have a black hole in the center of our solar system, and the Earth would do what? Besides get cold. Any speculation?
Is it like sucked into it?
The most common misconception, which is one of the reasons I asked this question. In fact, no, because the mass of the sun hasn't changed. The Earth would still just keep orbiting. But since nothing can escape the sun, the light would no longer come out. We would get very cold, and it would be dark. I guess we could survive for a month. I'm not quite sure. The Earth still has its own heating source, so we wouldn't freeze immediately. Now you can go through the same thing with the Earth. How if the Earth could somehow magically shrink, how small does it need to be in order to become a black hole? And the Earth, cutting through to the chase, if the Earth shrank down to the size between my 2 fingernails right there, then the Earth becomes a black hole. Now, I talked about our sun shrinking if it could somehow shrink down. There's 2 major things going on with stars. You've got this radiation that's getting out, and then you have the gravitational pull pulling in. So you need to have enough mass so that when it runs out of enough radiation trying to get out, that it will basically collapse in on itself, it'll shrink down. Our sun is not expected to do that. Our sun, the amount of mass in our sun is small enough so that eventually the radiation will actually win between the battle between the 2 things, and our sun will start to expand. Eventually, our sun, according to current theory, our sun will be here. We will not be, because as the mass disappears from the sun, the gravitational pull is weaker, and so the Earth will start moving farther away. So the Earth will never be consumed by the sun, and I have heard people say that. It's sort of a misconception there. The sun will be here, but we will not be. We be in the Earth. Humans will long be gone. So, 2 things can happen. If you have enough mass and you have this pressure pushing out on it, the radiation trying to get out, and this gravitational pull pulling in, when the radiation sort of runs out, when we don't have enough radiation to keep it puffed out, then the star, the big enough star, will collapse in on itself, and one of 2 things will happen. 1, it will shrink and compress and become a black hole, or 2, it will shrink and so much pressure gets pushed on this thing that it will explode into a nova or supernova. So that's it for the big stars, just not us. And that is part of the future. If you really wanted to see speculation about what is going to happen in the future, there's a video out there by, I think, Melody Sheep is the the person who produced it, or the group, whatever they are, where they do basically the rest of time, all the way to the very end of the universe. It is fascinating to watch.